Problem number 3. Factor holes, vertical asymptotes, x-intercepts, y-intercepts, then I'm ready to graph. Let's factor first. All I can do is factor out the bottom. The top remains the same. This is a difference of 2 squares. Always remember all of these are to the first power. Very important to identify and remember that. We have factored. Next, what we're going to do is we are going to identify any holes. We don't have any holes because none of the factors cancel out. The next thing that we're going to do is we're going to identify the vertical asymptote. You have 2 vertical asymptotes right here. You have a vertical asymptote at x equals 1 with opposite behavior, and also x equals -1 with opposite behavior. So both of those are going to be your vertical asymptotes. Your horizontal asymptote, the degree phi, remember the degrees always determine the horizontal or the oblique. The bottom one, the degree phi, so I know my horizontal asymptote is y equals 0. For the x-intercept, we're going to grab that from the top. We only have one x-intercept, that's at +3, 0, with straight through behavior. Remember your y-intercept, you have to plug in numbers. Look, you can plug it into the original. What would happen right here if you plugged the x on top, a 0 on the top for x and a 0 on the top or on the bottom? They would cancel out. That's -3 divided by -1, which is a +3. The y-intercept is 0, +3. We have everything we need to start graphing. So I'm going to go ahead and pick up my red pen because usually what I graph first are holes, but remember we didn't have any because nothing canceled out. So now what we're next is to graph all of our horizontal and vertical asymptotes. So let's draw an asymptote at +1. Remember it had opposite behavior because it was to an odd exponent. Same thing over here with the -1. Remember we had a difference of 2 squares when we factored that. So, all right, after you draw that, remember we had a horizontal asymptote at y equals 0. When your horizontal asymptote is right on the x-axis, just guys kind of try to bold it out as best you can. Make sure I'm able to see. Make sure you just kind of extend a little bit. Let's go ahead and write y equals 0. All right, now I'm going to grab my blue pen. I'm going to go ahead and plot these intercepts. So 3, 0 is going to be approximately right here. Now, it's really bothering me because I just drew a point on an asymptote. Here's how asymptotes works. Sometimes they cross horizontal. Sometimes they cross oblique. Never, ever, ever, ever do they ever cross a vertical line. So it's okay, it still makes me a little upset, but never ever here, never ever here, never ever there. All right, so there's my x-intercept. I had a y-intercept at 3, 0. I'm sorry, 0, 3. Okay, and that's really all we have to graph this, and that's really all we need to make this sketch. Now look, I don't know if the graph starts up here and crosses down, or if the graph starts down here and crosses down. So I can't really focus on this section. But I have enough information that I need to start here. Where is the point? Is it above or below the origin? It's above the origin, which means the graph is up here. What do graphs love? Asymptotes. So what's happening is a graph is up here. It's swinging through the y-intercept. And remember, there's no doorway down here at all. It's not going to go down here. It's going to go right back up and hub the asymptote. Look what we wrote. We wrote opposite behavior. So if you drew an up arrow up here with me, you need to hop over to the other side of that vertical asymptote and draw a down arrow next to the down arrows. The up arrows and down arrows are always next to each other. Oh, so now we see, if it's down here, it's going to cross over. Don't draw that up here. Remember, you have an asymptote. Even though it crossed it, it still wants to hug it. So it's going to look like that. Notice I had two vertical asymptotes. How many ever asymptotes you have, you add one to that. That's how many branches you have. I have 2 vertical asymptotes. That means 3 branches total. Hop over the other asymptote. Draw the other, opposite in behavior. No doorway to the other side, so this little branch kind of behaves like that. There's no ordered pairs. All it can do is hug the asymptotes. That's problem number 3. Let's go ahead and review these points. Did we have a hole? No, nothing canceled out. Did we have an x-intercept? Yes, there was only one factor at the top there, so we know that that's 3, 0. It had a multiplicity of 1, which means it went straight through. Remember my y-intercept was 0, 3. How did I get that again? Remember, you just plug in 0 for the, and you can use the original if you guys want. Plug in x for the top and bottom. That's going to be -1 or -3 divided by a -1, which is a +3. Vertical asymptotes come from the bottom. You had 2 factors there, which means you had 2 x-intercept or 2 vertical asymptotes. And they both had opposite behavior. I'm just going to write this on the same line. How did I know they had opposite behavior? Because they had an odd exponent of a single power. 1 is odd. Horizontal asymptote. Remember, we had y equals 0. Since I have something here, never going to have an oblique here. And that's going to be all of your answers for problem number 3.